Okay, now let's play with this. So we have both the cluster Ambari and HDP and Cloudera. You can choose anyone. So let's choose again Ambari, and I will let you know through this. Okay, this is resource manager, node manager. We do have 3 node manager, and what we can do is basically we also have a sqoop. Okay, now we need to understand each of this. If you see this HDFS, we already have gone through the architecture of it, and there is a name node, secondary name node, and data node. Currently, we do not have high availability of name node, so secondary name node is there. It will do the checkpointing process and keeps the metadata refreshed on the name node for FS image and edit logs, right? So we already gone through this. Yarn is also almost clear: resource manager, node manager, and then hidden thing is application master, and it also has one history server basically. That is a part of this MapReduce history server, MapReduce 2. When I say MapReduce 2, so this is the MRV2 version that will actually have the newer APIs to conduct the MapReduce jobs, MapReduce algorithms. So here this history server, it actually is on the only you can say the use of this history server is to keep the logs for longer time of MapReduce. So whichever job that gets submitted onto your cluster, Yarn will serve all its resources to it and then make it completed. And once the things are getting completed, basically you will get the logs saved in history server for longer time, maybe 6 months. Then you can have some archival procedure or some archival policies that how long you want to keep the logs for the previously submitted or completed jobs. Okay, so mostly it is 6 months to 1 year. Why? Because suppose if you really want to look back into the time in order to check how your cluster is behaving, how your cluster is acting like kind of thing in terms of resources, how it is grown to this point. Basically you may sometimes require to analyze those previously completed job, okay, in terms of its logs. If the logs will be saved, definitely will come that okay, this job was taking a very less time, or now was taking very high time, and then now it is taking very less time or high time. So basically if you are having a recurring job that will be getting submitted on every day, so 6 months, by 6 months down the line, you can just compare that on daily basis how it is grown. Either the data size has grown, or basically if you tune your cluster and make it more faster, or it was like slower than the previous or faster than the previous. All that kind of analysis is required for you to have the logs of previous finished jobs. Okay, so that is the kind of history. This is running on port 19888. Okay, so if you go to the config of it, MapReduce, and try to search 19888, that is the default port on which your history server will listen. Okay, so I will try to find 19888. So if you see HDM master, this is 190. So it is like MapReduce job history, web app address. So from here you can easily see all the previously finished logs. And on Yarn, basically there is 8088 port where your resource manager runs. Okay. Now we will pick. We will try to pick Hive, Pig, sqoop. Okay, these are like some data that will play with the MapReduce. Okay, and we will just go through the architecture of it first, and then we'll start submitting some commands. We will run some sqoop commands and try to, because you need to be understand that how does this work, how developer actually use your cluster. Okay, if you know that, basically you can easily fine tune your cluster. So let's start with sqoop. Okay, sqoop is already installed, and I will just try to show you something. So it's like HTTP. Okay, I need to reconnect. Okay, so we have MySQL. It is it running or not? MySQL. User root. Okay, so we are having this MySQL database. What I will do is I will put some data into it. and then I will show you that how you can utilize a scoop in order to pull this data into your HDFS. Okay, so I will say create database that we are going to use for our own purpose. Create database, I will say hadoop underscore example. Okay, and then I'm going to use it, and I will create a table inside it called create table school. Okay, and then I want to have serial number as integer, and I will say name as a string, basically character with 10 maximum character in it. Okay, so this is a schema defined for it. You can say describe table and you will get the describe table, or describe school, and you will get the information about the fields. So there are two columns in it and their type. Okay, now you can insert value into. So currently if you do select star from school, basically you won't get anything because there are no records. Let me insert something into school values, and let's say one, I will say hadoop, right? And set, okay, I think one at a time. Big data. These are two simple records that we have feeded. Now if you do select star from, you select star from school. Okay, you have got this two records. Come out of it. You will now run, so you can also, so you can do switch user HDFS. Okay, and you just try to check where you can bring that record. So currently you do have this many directories in Hadoop HDFS. Okay, and let's get into /user/ hadoop fs minus ls /user. Let me just check what are all the directories under user. We do have /user /hive. This is a general directory where we mostly bring the data from a sqoop or using a sqoop. Currently there is nothing, so what I can do is I can create a school directory inside it. Okay, so automatically it will be generated. Now I can write a sqoop command, so I will say sqoop. Now there are two things we can do with a sqoop. Currently if you just say sqoop and enter, it will give all the options that you can take for the sqoop, but again you don't need to care about what, you just need to understand that how sqoop submits MapReduce. Okay, ultimately it is going to fire a MapReduce and you just need to watch it whether it is going successful or not. So you say sqoop help, and there are a lot of sub commands that you can run with. I'll quickly tell you one import command. So these are all the things that you can do with the sqoop. So just do sqoop import connect JDBC MySQL and then the name of your master HD, where our sqoop client is there, HTTP m2 dot cluster.com. Sorry, here our MySQL is stored, so 3306 is the port on which it is running. Okay, and then hadoop underscore example is the database from where we need to pick the table. Okay, then you also need to specify the driver. Okay, so let me pick the driver where it is. Okay, so we need to provide username, root. We also need to provide password in clear text form, let me mark in this case. Then we need to specify driver, table, and target directory. Driver would be MySQL JDBC driver, table is school that we are going to pull, and target directory would be our /user/hive and school, that is will be automatically created. So till here we do have the directory in HDFS, but this school is not there, so it will be automatically created once we start pulling the data from this table to hive. So -m1, it will specify that since our table does not have any primary key, okay, sqoop is not having any idea how to break it, so basically it will ask us to provide only one mapper at a time. Okay, so let me just run it, let's check if it goes well. So it has started beginning import of a school. Now if you see, it is connecting to resource manager on this. This is 8050 is the backend port of it, and now submitting the application this. Okay, now you can easily monitor it through. So this is our HTTP. You can have 8088. You can have 19888, and currently if you see, it is running accepted undefined. You can keep refreshing it. Again, from the backend you can duplicate it and just run yarn top. Keep refreshing. So it has started with map 0 reduce 0. Running means now it is, if you see the 2 containers, so at max 2 containers are required. Okay, sorry, minimum 2 containers are basically required in order to have your task going, because one container will be used by application master, second container is where your task will be submitted. And now the things, we have imported the records from MySQL database into our Hive HDFS directory. Now if you can go there, hadoop fs -ls, say user hive and school is a directory that automatically should be created. And you got part-m. Part-m means since we have specified only one mapper, only one part file will be generated, and m means it is output of mapper. There is no reducer run as of now in sqoop. Okay, there would be a question sometimes asked in interview that in which scenario the reducers will also run. So that is something called incremental last modified, is a way of importing the data that will replace the data which was changed on the MySQL side but not on the Hive side. So whatever change record that comes in MySQL side can be automatically sync onto the Hadoop side, and there the incremental last modified run. But again, I don't think that would be an admin question. Okay, so basically you are responsible that this jar or whatever this task, right? So if you see this task, it is over on 8088. If you come here and now refresh it, you will find that 0053 0053, it has come over here, right? And now the jar that got submitted was a school.jar. You can again check that what does it, this school jar will. So school.jar is basically the program, Java program that got created by sqoop. Okay, so what sqoop does at the back end is whenever you run this command, okay, that is sqoop command, whenever you run this command, it will actually create a jar. It will automatically create a program of Java at the back end, depending on, if you try to just go through the log, I will just tell you quickly that how does it do the things. So this is the command that we have submitted. Okay, and then it did this select from school, okay, where 1 is equal to 0. It means that it, in this particular statement, it just bring the schema of the school table, which is having a serial number field and one name field. And finally, it actually creates a jar, and that jar does have the actual program. So if you see this school.java, the school.java is the file in which this sqoop at the backend will create a Java code, and that Java code will be used in order to connect to the MySQL, fetch all the records from that table and put it into HDFS. Okay, basically this school.java represent a one pure record from your table, and then since every record is having a similar schema, similar data types, the same object will be used for multiple rows to fetch it from the MySQL and put it into HDFS. Okay, and that's why it had, then it created a jar, that is the writing the jar file, that is school.jar. Okay, and that school.jar gets submitted as a Hadoop jar, okay, at the backend. You never know that much process in detail, and finally you are up, and then finally you got this map reduce job. So this job gets submitted, map 0 100 is 0, and finally the complete thing is done, and you have got your data. And currently there is nothing running because there is no job as of now running, but then again it will tell you that these 30 GB is available, 3 cores are available, and that you can use. So if you come out of it, so these two things are very important. Now if you can go and try to check the logs of it, you will go here, then you can go on map on reduce. So there are no reduce tasks running, so just open map. If you open this, okay, currently it is hosting where a default node over here, so I will just open the logs, and here you will find container. Now you can go further on this log, and there are a lot of things that will come here. So this is the container ID. If you see container E and something, it's very long. Okay, so this is the container ID that get launched, right? And again, when you talk about container, it's again a JVM, okay, Java Virtual Machine. Okay, and one good thing about here is like when you come down to the container thing, and since it is a kind of JVM only, container JVM, and this JVM need not to be killed and restarted. So once the container is started, the task will come, use its resource or environment, get finished, just finished, then the next task will come into the container. So that is a kind of a reuse of JVM. Okay, in the earlier design, basically it was killing and restarting of JVM. That would be a very time consuming process, and it will make your overall job finish very slower. Okay, so there are a lot of improvement in the yarn design they have come up with, and that one of is like the reuse of container JVM, because container once created cannot be destroyed. Okay, the container JVM will be there. You just need to submit the task. The task gets finished by utilizing its resources. So this is container. Okay, search more on this. And this is second container. If you see, okay, no, this is two only. So we should have in the logs, basically we should have the container, I think one for application master and the second for the tasks one where it gets submitted. Okay, we can click here for the full logs. Now this is the complete log actually from top to bottom. So now you can study it and get more inner information, but again it is you just need to know where to check for it, okay? And then again, if you go through it, you will get more insight about it. What are all the class path of a job? Sometimes it might happen that the job did not find any jar that is expected to be there in the class path or environment. Then how you will incorporate that, okay? Sometimes you will definitely see the error of class not found, method not found, okay, array out of index, heap out of memory exception. These kind of exception you will generally see. Okay, so this is where you will come and then try to find its root cause, that why it is so. If you feel that that is somehow that cannot be, because ultimately being an admin you can just change some properties, increase the size of container, generally that what you can do at the resources level, okay? Mostly you won't do much if it is array out of index or it is heap out of space error. It is somewhat that developer should think on that how to make it more workable, okay? But you should know that what does it sqoop do, okay? So sqoop is basically a tool, or sqoop is just a utility that will fetch the data from any RDBMS. So currently we have used MySQL because we have installed it and we do have its driver to connect it to it basically. But then sqoop can pull the data from Teradata, Netezza, SAP HANA. If you just provide it the JDBC connector of that database, and sqoop will just pull the data. Not only it will pull the data, it will also export the data, okay? But then again, export is not that much difficult. So what I will do is I will just go here on MySQL, delete the data, and I will just show you how to do the export, just the reverse way of import. And whatever data that we have just imported, we will just export that same data to the table. So I will, let me just go to MySQL, user root and password Hemant, and use hadoop underscore example is the database, and I will say delete. Currently we do have records, school, yes we do have. I am saying delete star from school, sorry, delete from school. So 2 rows got to delete, right? So now we do not have any records. Now after doing export, we should be getting records back into the thing. So instead of running a sqoop import, I will just convert that to be sqoop export. Connect rest, everything would be similar. Hadoop is going to user password, table is cool. Instead of export directory, I will pick target directory. I will say export dir. It's this. We don't specify M1, it should be okay. So this is started, and if you see it is again the same thing. It is created Java, it has created jar, and now it's using that jar to now export the data from reverse direction from HDFS to MySQL. Again it has submitted one MapReduce job. Again you can just go here and refresh, and you will be able to see that something is going on. So currently it's running. If you see 5 containers get used just to how come? So I will tell you so sqoop basically if you do not specify the number of mappers, by default it will use 4 mappers. So 4 mappers means 4 containers it got, and 1 container is for application master, and that's why you got 5 containers over here, right? So that is the logical explanation of why it is showing 5 containers. Okay, and I think by now it should be finished, and yes, we are okay. Error job failed. Why? Now very good thing to see the failure of job. Let's check. So first check this, why it is said to be failed. Failed task is job failed. it is failed, open it, go to logs. Okay, it should be moved to history server now. So this is failed, open the map tasks, these are all failed, let me open anyone. Java exception, access denied to user root at the hdps1cluster.com. Okay. Very good. So this is an admin problem, because now the developer thinks that it should be completed, because developer does not take care about whether the permission is granted properly or not. It's admin's, the admin should give the proper. Now it says that what has happened. Okay, we need to understand it. Basically, this time the export container got started on this cluster, hdps1.cluster.com. So hdps1.cluster.com is this other node in our cluster, from where it was trying to export the data from that directory, because HDFS is that directory can be easily distributed. So since it is distributed, it is uniformly accessible on all the nodes. So any node can have that container from where the export will be tried. Okay, and let's say it has picked this thing. Now in our MySQL, okay, it says that the root at the rate hdps1.cluster.com does not have the permission, using password yes. Why? Because I will tell you now. If you go to MySQL over here, okay, and if you say select star from, or select basically you need to select user, then password and host. From there is one table called MySQL dot users. I think it's not that one. Okay, let me just think. Users. So the table is user, not users. Now if you see a root, there is no entry for the host for hdps1.cluster.com. okay, so all this root entry, either it is for localhost or hdp2master.cluster.com or 127.0.0.1. so ultimately, if somebody is trying to hit this MySQL using root login, and from the host that is not matching to this hdpm2.cluster.com, then definitely it will not work. Then what should we do? So we need to create one more entry in order to allow HTTP S1 and S2 both, okay, because we never know that from which instance it will allow, or we should allow for all the roots. So we can have this kind of entry that for every entry it should allow, because you never know that how many entries are, because the thing is, if you add more nodes, how will you entertain that, right? So again, that is the exercise for you to find out that how we can add the root user. And currently why we are using root, because that actually root should be not used. Okay, in general practice there is some other user, but again this is a kind of activity. It's very good that we have seen it. So let me do that. What I will do is I will exit out of it. I will say MySQL admin